Hello, welcome to this lesson of our study of vectors and mechanics. So if you have not subscribed to the channel, kindly subscribe to support the channel. Okay, all right, just look at it and subscribe. Okay, all right, if you have subscribed, thank you very much for supporting the channel. All right, so today we're doing examples on vectors addition. Okay, so we're gonna use the ideas that we know in vectors addition to solve this question. Okay, so let's read the question together. Our first question says that relative to a first origin O, okay, so here talking about origin, the point A has coordinates this. Okay, so if I have, let's say, the origin O to be here, then the point A is relative to that. Okay, so A from O is like this. Okay, has coordinates 2, -3. Okay, the point B is such that the point B is such so that AB is this, and determine the distance B from O, which is our initial point. So it means that you are supposed to determine the distance of B from O, which is the origin. Okay, so this is what we want to find. We want to find the distance OB. Okay, this one, the distance, this meaning it's the same as the magnitude. Okay, so we use the idea of magnitude here. So it's like you have A or B somewhere here. Let's say if here is B and we've been given AB. Okay, so it means this point AB here means that A is moving to B. Okay, so from A to B. Okay, like that. So if I go to the next page, we'll draw the actual thing here. Okay, so this is how it looks like. If let's say here is my O and that A is from O. Okay, let me use a correct pen. Let's say here is my point and A starts from here to here. Let's say B also starts from here to here. Let's take it like that. Okay, and let's say AB is like this. Okay, let's take AB to be this. I hope this is okay. All right, so this is O. Here is, let's say, A, and here is, let's say, B. You are saying that OB has been given, that the coordinate at O, or sorry, at B is 2, -3, which in Cartesian coordinates will be 2i minus 3j. Okay, so on that line, this is what we have there. Okay, and then we have AB to be this, and AB is also 3i minus 7j given in the question. Okay, so our points or our task here is it AB. We're supposed to find AB rather. Okay, the arrow here shows BA. Okay, it's supposed to be AB like this. Okay, and we are saying it's 3i. Okay, 3i minus 7j. Okay, and we are supposed to find distance, the distance from here to here. Okay, which means you are supposed to find the how do you call it, the vector OB. Okay, so using the triangle law of vector addition that we just studied, we're saying that if you have the arrows moving in the same direction, you add them, it should be equal to the arrow moving in the opposite direction. Okay, so the arrows moving the same direction is this one, this, and this. Okay, they are all moving in this direction. You can see it's like this. Okay, for them that is how they are moving. Okay, but this is meeting them at this point. Okay, the OB, so you can see that the OB is in the opposite direction. Okay, it is meeting them here. It means that if I add vector OA, okay, OA plus AB, it should be equal to OB. Okay, in terms of this whole thing is in terms of position vector. You can see we said that in position vector, the initial point of every vector is what, O. Okay, that is the position vector of a point. All right, so here the position vector OA, OA, and here A is starting from That vector is starting from 0, or sorry, origin O, then to the point A, okay, and we have OB here. So it means that this OB here, this vector here, is given by this formula, okay. This is what we have here. It means if I'm to find my vector, then OB will be equal to simply OA is given as 2I minus 3J, and plus AB is also given as 3I minus 7J. So you add them component wise, okay. So I take OB, then it will be equal to, you add the i's to I, so I have to get 5I, then minus 3 minus 7, so I have minus 10J, okay. Sorry, the J should be small j, okay. So these are what we have here to be our OB. Now, this is not our task. Our task is to find the distance from O to B, okay. If you remember, distance from O, that's B from O. It means that, sorry, you should come to this one, okay. Distance from this is what we have. Let me see. The question says that we should find the distance from O, that is B from O. It means if you are standing at B here, okay, what is the distance of B from O? I mean this distance, okay. Do you now understand it? That's what we want to find. So the distance would then be equal to distance OB, okay, and that will be equal to, we said that the square root of the sum of the squares of each component of OB, and the components are 5 and negative 10, okay. So it becomes square root of 5 squared plus negative 10 squared, and this will be square root of 25 plus 100, okay, and this will be equal to square root of 125, and this is the same as 5 square root of 5 units, or whatever you want to put it, okay. That is the solution, okay, to this question. Now let's move ahead to the next question, which is a bit difficult than this. Now the question is saying that the point A has coordinates -2, 4 relative to a first point or first origin O. So this point A here has coordinates this relative to the first point O, or the origin. Find the point B such that BA is this, okay, BA is this, and determine the distance of B from O, and calculate the angle of OAB, or calculate the angle OAB, okay. Now here is in like 3 questions in one, okay. We are supposed to determine the point B, then the distance of B from O, meaning you are supposed to find this distance, okay, distance OB like this. You are supposed to find the angle OAB. Okay, so quickly let's look at a scenario here. Now it's like this. Like I said, you have the origin, okay. After here we'll discuss about some important formula in terms of position vector, okay. So I have, let's say I have O here, and A is moving like that, B is moving like that. You can draw them anyhow you want, okay, and this is how it looks like, okay. So let's say this is my O, this is my A, this is my B, and we've been given point OA, or at A we have -2, 4, okay, and this is OA, that is the position vector of A from O, okay. And on that I can write this in Cartesian coordinate as -2I plus 4J. I've taught this in our first discussion in vectors and mechanics, how you transform this to that, okay. And this is also like this, from B is from O, and also we have BA, okay. So it means BA means we are moving from B to A, so we have BA like that, and it's 5I minus J, okay. So what we don't have is this point, okay, this side. Now with that side, what we can do here is that looking at these arrows, okay, the ones that are moving in the same direction are this and this, okay. You see that they are all moving here like this, okay. But with the other one is moving opposite here like this to them. So it means the summation of the ones moving in the same direction is the same as the one moving in the other direction. Okay, so you say that OB plus BA, okay, should be equal to OA, is the one that is moving in the opposite direction. So sometimes you can just look at the directions and you use it, okay? Or I'll teach you a different formula after we are done with this, okay? So now we want to find OB. So OB is simply equal to OA minus BA, okay? So simply we just put our values or our things in, and so we have OB here, okay, being equal to OA is giving us minus 2I plus 4J, then minus BA is giving us 5I minus J, okay. So it means that we'll get something like for OB we'll get something like this, minus 2I plus 4J, okay. Let me write it to work for you. Plus 4J, then minus 5I plus J, okay. So it means I'll get OB to be equal to minus 7I plus 5J. So that is my OB, okay. So our task here is to find the point B. So the point B from O will be negative 7 comma 5, okay. That is the question to the first one. Find the point B, okay, this one, such that you have that, okay. So that is it. And then the next question is, you're supposed to find the distance B from O, meaning you are supposed to find distance OB like this, and this is equal to the square root of the sum of all the squares of the individual components. So individual components are negative 7 and 5, and so if I square negative 7, I'll get negative 7 squared here plus 5 squared, and this will give me square root of 74, okay. That is the answer to this unit. If you want to add a unit to it, okay, that will be it. Now the last question is saying that we should calculate the angle OAB, so we can draw the triangle in a right way, okay. So let me draw the triangle properly for you to see, so that we can use some formulas to calculate our angle. So if I draw the triangle, it looks like this one, okay, and I have this here, and I have this here as well, okay. So let me number them so that this is for A. This part that we solved here is for A, okay. This is for A. This one is for A, and you're solving for B like this, okay. So now with this, A is here and B is here, and let's say O is here. So from what we know, we are finding the angle OAB, meaning this angle, okay. So we check the one in the middle, okay, and then we want to name it, let's say theta, okay. Now with this, the only way we can use to find this is using what we call the cosine formula, okay. So you can name this side here, the distance here, let's call it OB, okay. Distance OB, automatically that is how it is being called. We are not the ones calling it that, okay. So let's say OB is here, okay, and we have the distance here should be AB or BA, any way we want to call it, okay. In the diagram it was like this, okay, then it was BA, okay. So anyhow you want to call it, let's say BA or AB. In terms of distance, BA and AB, their distance are the same, just that the directions will be different, okay, meaning their magnitude will be the same. Then I have distance OA, okay, like that. Now I know my OA, I know my BA, and all of them. So I can find distance OA. Okay, let me put the bar here, and this should be equal to square root of my A is what? So I just go back to the question and check my A. My A is minus 2 comma 4, or minus 2j, sorry, 2I plus 4j. So what I can say is negative 2 squared plus 4 squared, and this will be square root of 20. Okay, and the my BA, I know my B, sorry, I know my BA rather. So my BA will actually be equal to 5I minus j. So I have 5 squared plus 1 squared. Okay, I have 5 squared plus negative 1 squared rather, and this is square root of 26. And I know OB already. For OB, we've calculated for the distance, and that was square root of 74. So it means our actual triangle looks like this. The triangle I want us to use to find the, the angle, it looks like this. I have this here. Want to use a rule called the cosine rule. So before you can use, I have to calculate all the distance on the triangle. Okay, that's how it works. So around the triangle, you just calculate for all the distances. Okay, that is why we are wasting our time here calculating for all the distances. And then here is O, have BA, and here is what, square root of 26. That is the distance here, and here is square root of, no, here is supposed to be 20. OA is 20, square root of 74, and square root of 26 rather. And here we have an angle called theta here. So from the cosine rule, this is how it states. It states that the distance of, or the distance that is opposite to the angle that you are calculating for, okay, squared. So it's like this: OB squared should be equal to the sum of all the distances squared. Okay, so it's like this: sum of the square of the distances. Let me put it that way: OA squared plus then BA, or AB squared. Let's use BA because BA was rather given in the question. Then minus 2, then OA BA. Okay, all of this, the product of all of this, then times cos of theta. Okay, let me write it well so that you don't get confused. The cos of theta is actually multiplied to the minus 2 times whatever that I wrote. Okay, so it's like this: the opposite distance to the angle we want squared should be equal to this OA squared plus BA squared, okay, minus 2 OA BA, okay, cos of theta, which is what we want to find. Okay, so it means that we can make some subjects here. Let me make it straight away. So I have OB squared. Okay, so if I put square root of 74 here, okay, squared should be equal to OA is what? So I have square root of OA is 20, square root of 20, so then squared plus square root of 26 squared minus 2 square root of 20 times square root of 26 cos of theta. Okay, so it means that I'll get something like 74 here should be equal to 20 plus 26, okay, minus 2 square root of 20 times 26. Okay, 20 times 26, then cos theta. Okay, I hope you get what I'm trying to do here. Then it means that this whole thing will give us negative 2 square root of 20 times 26 cos theta will be equal to 74 minus 46. Okay, and this will be cos of theta should be equal to 74. I don't know the answer here, so let me write it like that. Okay, so if I divide through by negative 2 square root of whatever, I have 46 minus 74 over 2 square root of 20 times 26. Okay, so theta will be just the cos inverse of the whole of this. So cos inverse of 46, I don't know, I've not calculated, but I know the angle. I'll punch everything straight away in the calculator, so that is why I'm just maintaining like this. And this will give me theta to be equal to 128 degrees. This actually is 127 point something, but I just approximated it to the nearest whole number. Okay, so like that is the angle OAB from the question given. So you see, this is very simple, but then if you don't take care, you get it wrong. Okay, so what you can do is, the formulas I wanted to teach you is, in terms of position vectors, AB is always giving us OB minus BA, sorry, OA. Always this formula works. Keep this. And then BA is always also giving us OA minus OB. So it's as if the last one minus the first one, always that is how it works. Okay, so if I give you like something like angle triangle, or let's say vectors PQ, okay, this will be equal to OQ, okay, minus OP. So just keep these formulas in mind. Okay, keep them and it will always work for you. Thank you, and don't forget to subscribe to the channel. See you next time.